Angles don't have to exist in a vacuum by themselves. We often put them on the coordinate plane. And if you put an angle on the coordinate plane, you always line it up so that one side lies along the x-axis, the positive x-axis. And we call that the terminal side. So that would be right here or right here in this example. And you can either open your angle up in a positive direction or down in a negative direction. So this would be like positive 30 degrees or 45 degrees, and this would be like negative 45 degrees or negative 30 degrees. This little ray here, the arrow that we're actually doing all the rotating when we open up or down, is called the terminal side. All right, let's talk a little bit about the coordinate plane. Just to refresh your memory, if you don't remember all of this, there are 4 quadrants. So wait, this is the positive x-axis, and this is in the negative direction. This is the y-axis in the positive direction and in the negative direction. There are 4 areas on the coordinate plane. We call them quadrants. So this is quadrant 1, 2, 3, 4. We are going to be drawing angles on the coordinate plane, so it would help for you to know some of the major measurements at all the different axes. So if we start with our angle right here and we don't open up or down, it's going to be 0 degrees. If we decide to draw our angle like this where it opens straight up, remember it starts on the positive x-axis, but then we rotate the terminal side to point straight up, this would be 90 degrees. If I continue around and decide to make it point straight backwards instead, this would be 180, 270, and 360 if we went all the way around to make a full circle. The only way you can tell the difference between 0 degrees and 360 degrees is if you actually see this curve drawn to show you that we went through a full circle. Otherwise, they look like it's just one angle or one arrow. You can't even see the 2 arrows for your angle. Okay, so I could ask you, where would a 200-degree angle lie? You need to know, okay, it's positive, so it's going to open up. It's 200 means we have to hit 90, then 180. We're not quite over here at 270, so 200 degrees would be somewhere around here in quadrant 3. It would open all the way up to there. I could also say, okay, well, where would a negative 300-degree angle lie? All right, negatives will start 0. Now we have to open down. So if we open straight down, it's negative 90, negative 180, negative 270, and then negative 360 is all the way around. So negative 300 degrees, we hit 90, 180, 270. We don't quite get to 360, so negative 300 degrees would be somewhere around here, and this is quadrant 1. 1, 2, 3, 4. I could also ask you about radians. Let's go back to our original picture here. So in radians, again, this is still 0 radians. But now if I was going to open straight up, 90 degrees is the same thing as pi over 2 radians. So half pi. If I wanted to open straight back here instead of 180, this would be pi radians. If I continue around and I decide to curve around and open down, this would be 3 pi over 2 radians. Then if I continued my circle, I would have 2 pi radians. Remember, 2 pi radians are in a circle, and 360 degrees are in a circle. Okay, so I could ask, let's go to a new picture. I could ask, in what quadrant would a 5 pi over 6 radian angle lie? All right, well, just look at the fraction here, 5 sixths, versus this is a 1/2 pi over 2. This is just a 1 pi, 3 halves, and 2. So where would 5 sixths fall on that range? Is it between 0 and a half, 1/2 and 1, 1 and 3 halves and 2? That's what you need to think to yourself. Well, 5 sixths is somewhere between 1/2 and 1. So 5 pi over 6 would be about here. And this is quadrant 1, 2, 3, 4. So this would be quadrant 2. And I could do one more example. What if I asked you where would 7 pi over 4 radians lie? Okay, again, we're going to compare it to our fractions. Is 7/4, maybe it helps you to actually convert that to a decimal, because decimals to me are easier sometimes than fractions. That would be 1.75. Is that between 0 and 1/2? No. Is 1.75 or 7/4 between 1/2 and 1? No. Is it between 1 and 3/2 or 1.5? No. And is it between 3/2 and 2? Yes. 1.75, 7 pi over 4 is somewhere around here, and that is quadrant 1, 2, 3 in quadrant 4.